We are ready to go. So thanks for coming, everybody. My talk today is going to be a bit about Flux, but I'm also going to be talking a lot about the future, about what we're building towards with InfluxDB 2.0. So I'm going to use Flux as kind of a way to highlight some of the features that we're building in 2.0. Some of this will be stuff that exists today, that actually ship today, and a lot of it will be stuff that will be shipping in the near future, work that we're doing over the next 3 to 6 months. So first, let me talk about Flux just a little bit to introduce it. What is it? It is a data scripting language. And we call it a data scripting language because the idea behind it is it's not just for queries. It's for working with data. And that could be time series data, or it just could be data that you want to do analysis on. As a language style, it's functional in design. It looks like a functional language. The whole thing is MIT licensed. We decided to license it under a very permissive license to get, ideally, the broadest adoption possible that we can with the language. And that applies to the language itself, as well as the runtime. And the runtime is basically the language interpreter, but also the query engine. So it's a language and a query engine kind of rolled into one thing. And because we wanted it to have a life of its own outside of just InfluxDB, we created a separate GitHub repository for it. So basically, you can see here, this repo is already public. It's InfluxData/Flux, and everything in the language is here, right? And InfluxDB actually imports it as a library that you can use. But that means other projects written in Go could also import it. It can be used with or without InfluxDB. But let's talk really quickly a little bit about InfluxDB, and more specifically, InfluxDB 2.0. Now, I don't want to overstate the case, but I would say that InfluxDB 2.0 represents the biggest shift in our product since we did the upgrade of InfluxDB 0.8 to 0.9. How many people were InfluxDB users at that time? Anybody? Just a handful. OK. So the thing that's very different this time around that we weren't able to do with the 0.8 to 0.9 transition is that this one has a clean migration path. Before, when we did 0.8 to 0.9, we basically told people, this is a new product. It's still called InfluxDB, but ostensibly it was a brand new project. And we provided no migration path because there was no way that it made sense. In this case, with 2.0, there will be a clean migration path so you can migrate your data because of the fact that the 2.0 functionality represents a superset of what you can currently do with InfluxDB 1.7. And the other thing is, even though 2.0 has an entirely new API that's designed from the ground up around these specific use cases, there's a compatibility layer in there, right? So you'll be able to write to a 2.0 instance as though it's an InfluxDB 1.7 instance. You'll be able to send InfluxQL queries to it and get back results in the old response format. So you can make that migration gradually over time rather than trying to engineer a big, like, flip-the-switch change. So even though we are designing a new language and a new query engine and a new API, we're still very much supporting the things that are popular in InfluxDB 1.7 today. So this work is happening in open source right now. It's MIT licensed. The API is designed from the very beginning to be multi-tenanted. So within the API, there's a concept of organizations. And then within organizations are all the things that you have beneath that, right? You have users, you have what we call buckets, which are like the new databases, there are tasks. And the important thing to note about 2.0 is the way it will be delivered in open source is actually it's going to look like Telegraph, InfluxDB, Chronograph, and Capacitor all rolled into one thing. So it's basically the TIC Stack in a single binary that you can run and operate. And this will be delivered in a few different ways. The first is open source, right? A single server that you can install and get the entire set of functionality. We're going to have a cloud-based version that is multi-tenanted, and you can sign up for that, and it'll have usage-based pricing, much like what you see in AWS or the other cloud providers. We'll also have dedicated cloud instances if you want to have your own cluster that's dedicated to your organization, and you can create organizations and scale that out yourselves. And then we'll have an enterprise on-premise offering of the product. Basically one that's deployable at a smaller scale, and one that's deployable at a larger scale within your own Kubernetes infrastructure if you're running that. So I wanted to highlight this piece really quick, because I kind of glossed over it quickly. But this is actually, I think, one of the most important things about 2.0. Ultimately, we're killing this idea of the separate stack. The TIC Stack is actually an artifact of how the company was built up over time, right? In 2013, we created InfluxDB as a project. I started giving talks about it. It took off pretty quickly. People started using it in production against our guidance. But what we saw over the course of the next 6 months after we released the initial project was there was a common set of problems that people were trying to solve. How do they collect the data? How do they store and query it? How do they visualize it? And how do they process it for monitoring and ETL tasks? So basically in 2014, I went out, I talked to some nice venture capitalists, and I convinced them to give us a Series A round of funding so that we could build out a team to build these other pieces of the stack. And TIC I had picked as just basically a marketing term. It's an homage to time series in finance, because in 2010 I had worked for a fintech startup. A TIC is like an individual data point within a time series, like a ticker tape. So the thing is, TIC is dead, but all of that functionality we're rolling into 2.0. It will have all of this stuff built in. And actually, Telegraph will be built into the 2.0 binary as well, which means that InfluxDB 2.0 will support both push and pull metric styles out of the box without any additional tooling. Basically, any of the plugins in Telegraph that hit network accessible services can be pulled in from InfluxDB itself. However, we're going to continue to develop Telegraph as a separate project because people deploy it so widely across their infrastructure, and they want something lighter weight to be able to just deploy the collector. And the thing about all of this is bringing these projects together under one cohesive whole means we can design a consistent and well-documented API. Chronograph, Capacitor, and InfluxDB all have APIs, some documented well, some not, but they're not consistent. The idea here is we want to have people not think about the individual pieces, but really just about the API they're working with. There are endpoints for defining data collection. You can write data, you can query data, you can define stream and batch processing jobs, you can store dashboards, you can define dashboards that you can share. And all of this is basically defined in a Swagger file. So we're using Swagger to define all these APIs. Right now, this is in a repo called Platform. This is actually also open. But this is still, the API is still under high velocity development right now, so this isn't complete. So we haven't done the documentation yet, but this Swagger file is the closest thing to the definition of what that API is going to look like. The other thing that we're going to do in 2.0 that we haven't done ever before is we're going to develop and support client libraries officially, right? We want developers to be able to pick up these tools and work with the 2.0 API without having to write their own client library. So this is the set of languages that we're going to try and hit right out of the gate, but we'll be adding to this all the time. And the other thing we're going to do, which we haven't done before, is we're going to create visualization libraries in JavaScript. We won't write the actual library. More likely, we'll pick something like digraphs and stack on top of it. But we want to make it trivial for developers to create interactive visualizations in their own applications with data coming from InfluxDB, right? The less code you have to write to get an interactive visualization, the less configuration you have to do, the more you can focus on the actual app that you're trying to build and the business value you're trying to provide to your customers. So let's get back to Flux. I'll talk about this, and I want to kind of use Flux's functionality to highlight, as a way to highlight the things that we're looking at delivering in 2.0, right? So first off, there are a few different ways to run Flux. Right now, InfluxDB 1.7 is the one method that's supported. We cut the 1.7 release last night and announced it today. But in the future, there will be a command line shell So you can run Flux scripts like you would a Python or a Ruby script or something like that. And then obviously as part of 2.0. Now, I mentioned a lot of the stuff in this talk is basically future work. But there is some of this that actually already exists. And what we also released is documentation for what's in the 1.7 release of Flux, or the 0.7 release of Flux and the 1.7 release of InfluxDB, so you can see what functions we have defined. There's an easy getting started guide that will guide you through it. It's basically a feature flag that you have to turn on to enable it as an endpoint inside InfluxDB. But now you no longer need a separate tool to start working with Flux and querying the database using it. But for the stuff that's basically in the future that's not yet implemented, we also have the language spec online, and there's a bunch of stuff there. Like there's a whole ton of stuff in this spec that is not yet implemented, but it has pointers to issues where you can track what's going on and see what's happening as we develop the language. So this is on the Flux repo. All right, so let's talk really quickly about some of the language elements. And this is going to be kind of a whirlwind tour. I'm just going to blaze through a ton of stuff here. So hopefully you can follow with me. So this is an example query. We're pulling data from our Telegraph database, the auto-gen retention policy. We're looking at the last hour, and we're filtering it by the CPU measurement and the usage system field. So a few things you can see from this query right away. Obviously, the language supports comments. We have named arguments. We only do named arguments in Flux. We do not do positional arguments. And the reason we chose to do that is because we think named arguments adds to the readability of your queries. String literals are a thing. One thing to point out is we're talking about buckets, not databases and retention policies. So one of the reasons we decided to call it a bucket instead of a database is for people who have been database administrators, database means a certain thing in your head, right? It means like a certain layout in the file system and all this other stuff. Buckets in 2.0 aren't necessarily tied to that, and the design will be that you can have thousands of buckets. But in the meantime, what we've done is we've said the convention is going to be, if you're working in 1.7, the database name / the retention policy name. That way, if you define like dashboards or queries in Flux, you can migrate to 2.0 without having to update those definitions when you do so. So there's also duration literals as a first-class citizen in the language. There are time literals. We have this funky-looking pipe forward operator thing. So this is something we borrowed from functional languages like Elixir. And it basically just means take the output of the last function and pipe it to this function. In Lisp, this would be like a bunch of nested function calls and the parenthesis nightmare that you see. We think this is basically like a far more readable way to think about this kind of like basically flow of data from one function to another. We have anonymous functions, which you can pass around. Also, within the filter function, you pass in a predicate function, right? So you can represent complex logic about how to match against a record. And all of that kind of gets translated in the background behind the scenes into whatever is the most efficient way to run the query, right? Like the naive implementation of this would be the from function returns the entire contents of the database, and then the range function then filters that down, and then the filter function filters that down. Obviously, we're not going to do that. We take advantage of the way the data is indexed within the storage engine to make sure we query it as quickly as possible. OK, so there are variables. We have integers, floats, strings, durations, times, arrays, objects. All of this should look pretty familiar. So now I want to talk really briefly about what the data model looks like in Flux. And I think the data model and how we work with data in Flux is one of the things that is a differentiator in it. I think that's ultimately what will make programmers more productive when trying to solve data problems with Flux language versus picking up a general purpose programming language. So here's some example time series. One of the conventions we have is that anything with a leading underscore is basically like a system level thing. So the way we represent data in InfluxDB 2.0, like old InfluxDB 1.x data, is underscore measurement is the measurement name, and underscore field is the field name, and then the other tags are just the tags that you have on that data. But the reason why we represent it like this is so that within Flux, you can work with the data regardless of whether it's a field or a tag. And I'll show some powerful examples of that in a bit. So here we have a table. Basically, Flux functions generally view things as a stream of tables, which each has a set of records. And each individual table has a consistent, basically, data model to it, right? Like the types are consistent for, say, a column, right? So you have columns, you have records, individual records. And the other thing we have is this thing called a group key. So what the group key is basically the identifier for the time series that you're working with. And you'll notice that for the things that appear in the group key, every record actually has the exact same value for that thing. So what ends up happening here is we actually create a separate table in the stream for each individual time series. So when you send a Flux query, say we have this time series, mem free from host A, and then we have mem free from host B, and say we have CPU from host A, and CPU usage system from host A. So each one of those time series comes through as a separate table. And the behavior of Flux the language is basically like, by default, everything is grouped by star. That's how we put everything together. Now, you can shuffle that around, which I'll show in a second. But by default, everything's grouped by star, and you get a separate table per time series. So the way to think about this is you have a set of input tables, you have a function which does some sort of transformation, and then you have a set of output tables that are the result of that function. So here we have a query. We're looking at the telegraph database. We're looking at a small range of time. We're looking at the memory measurement and the free field. But the question is, when we call sum, what are we actually going to compute sum on? Well, one other thing in the language is we have a concept of default values for arguments. So arguments are optional if a default value is defined. In the case of sum, basically the aggregate functions and the selector functions, they have an argument called columns, and the default value for that is an array with underscore values. So basically it just says, by default, we're going to sum the value column. And you can actually sum multiple columns at the same time. But we're going to go with this, just the default. So say we have these input tables from the initial part of the query, right, the range and the filter. And we see we have host A and host B. We send that to sum. And then we have this set of output tables. And what we see is because sum's an aggregate, we've reduced each table to a single record. So what you have with these aggregates and with selectors is you have an end-to-end table mapping. There's a one-to-one mapping of input tables to output tables. So selectors like min and aggregates like mean have this sort of mapping. The other kind of functions are functions that have an n-to-m mapping. So you could be increasing the number of tables that come as output or decreasing the number of tables. And the reason you do that is because you want to shape your data into different collections of time series that you can then work with. So let's take an example using the window function. So the window function is a specific function basically for working on the time dimension. Here we're grabbing some set of data, and then we're saying window this set of data into 20-second buckets. So here's what that looks like. Here we have input. We have two separate tables. We can see like we have those individual data points across those times. We call window every 20 seconds. And because of the actual data that's in the input tables, we get a split of output tables where we have per time series, per 20-second window, a table of data, right? So in this case, we've gotten 4 output tables, and we have an end-to-end mapping of tables. As I said, window works based on time dimensions, and under the covers, the time dimensions that we look at are something called underscore stop and underscore start. Those represent the range of data for any given table, like the time range. And then underscore time is obviously the built-in time that we give to every single value. The other way to shape the data and to do transformations is through group. Now, you could actually use group to do time-based transformations as well, but Windows is just an easier way to do that. So let's look at what happens when we do this query, where we say we're going to group based on the region, right? So this is going to be our new group key. Here we have the input data. We see we have, data from two separate hosts, but they're both in the Western region. So when we group, what we get is one output table. So there's an M-to-M mapping of tables where M is basically the cardinality of the group keys combined that you have. And you can group based on any kind of column, whether it's a tag key or a value or whatever. And that's something you can't currently do in InfluxQL. You can't group on a field value. In Flux, that's trivial. You can easily group on any sort of field value because once the data arrives into the Flux query engine, it just processes it there, and it has no knowledge of whether, it doesn't care whether or not it was a tag or field or whatever. It's just tables of data. So I want to talk about some of the design principles behind the language. The first and most important thing is we want it to be usable. We want to optimize for programmer happiness, right? When we're having arguments about how to design the language or what a feature should look like or something like this, optimizing for programmer happiness and a user experience that is fun is more important than having language purity, right? Because ultimately, we want everybody to be a data programmer. A lot of the most interesting problems we're going to have to solve over the next decade of software development are data problems. What we want to do is we want to do like what VBA and Delphi did for programmers in the 90s. It made a bunch of people Windows programmers that otherwise would never have been Windows programmers because they made it easy to do. So obviously, like, we want everybody to be data programmers, but we don't want people to necessarily have to learn the language right out of the gate. Ideally, what they'd be able to do is have a user interface where they can work with it and they can get insight from their data without having to learn Flux at first. Now, this user interface is in Chronograph 1.7, which also got released today. Right now, we basically just have a script editing window that you can see there with syntax highlighting. We also have built-in documentation for the functions that are supported and what that does. But the thing we're starting to play around with now is how do we create a user experience where somebody can get to their data, and they can visualize it, or they can monitor and alert on it, without having to know Flux at all, right? So in this case, we have this thing that's called the Flux Script Wizard. We'll probably rename that. But basically, like, this is just a basic tool where you can select a database, you can select a measurement, you can select a set of fields, and you can select an aggregate, and it'll create the script for you, and you get a visualization. And we'll be expanding the functionality of the Flux Script Wizard over time to try and enable more complex use cases and more complex queries that are accessed just through point and click, not through actually having to write Flux code. We want it to be readable. We think you read more code than you write in most cases, so we want people who look at Flux queries to be able to reason about what's going on and easily read it. It needs to be flexible. So part of this is we're going to be hooking in with other systems. It isn't just constrained to InfluxDB. You'll be able to pull data from other systems and send data to other systems, and it needs to be flexible enough to allow this kind of behavior. And it has to be composable. Users can define functions, and ideally, like, we have a bunch of primitives built into the language, but over time, you define a bunch of functions that build up towards your use case so that there's less code that your users have to create to create more complex monitoring, alerting rules or queries or that kind of stuff. Testability is very important. This is one of the biggest bits of feedback we've had over the years with Capacitor, is that it's very hard to test. It's very hard to see what's going on. The nice thing about having this Flux as the unifying language is that you can seamlessly move from interactive batch querying to tasks running in the background, and you can test each function along the way to see what it returns. Like, the functional style means you have inputs, the function, and then outputs. So that's like the easiest thing to unit test in the world. We want it to be contributable, and I'll show what this looks like, but we want people to be able to contribute new functions to the language, contribute new connectors to the language, without having to understand all the complexity of the language implementation, or the query engine, or all this other stuff. And finally, we want it to be shareable. We want people to be able to share their code snippets with other people in the community and get basically value out of people solving the same problems. We don't want people reinventing the wheel all the time. So we'll take a quick overview at how we kind of view functions. We organize them broadly into 3 different categories. We have inputs, which are basically sources of data. We have transformations, which are things that, transform the set of tables. And then we have outputs, which are basically sinks, data sinks, where you're writing data to. So inputs, we're going to support a bunch of stuff. I'm not totally sure what we're going to support on day 1. From is from InfluxDB. We could have from Kafka, where you're pulling a bunch of data from a Kafka log. From a file, could be CSV, could be JSON. From S3, from Prometheus. We actually have a pull request up right now that takes some code that I wrote in August to bring it into the new engine style to basically query Prometheus data and work with it in Flux. From MySQL. The important thing to highlight about inputs is that Flux is not the same thing as InfluxDB. The language itself should be able to exist on its own outside of the database. It can pull data from many different sources. InfluxDB just happens to be one of them and the one we're supporting the most. So let's look at what this looks like in the actual repo. Here's the repo, and as you can see, we have 3 separate sections. We have inputs, we have outputs, and we have transformations. And the idea is we created this code structure so that people who want to contribute new functions would be able to jump into the repo and not have to understand all the code. They just need to understand what's in this specific area. So if we drill down into inputs, for example, you look here and we have a bunch of different inputs defined. And there's basically a .go file for the initial input and then a test file. And the idea is you should be able to define a new data source by just writing those 2 separate files and defining everything you need. So you have the tests all encapsulated there. As you can see, there are a couple of connectors like from CSV, from SQL. Those were kind of like the result of a quick hack day that we had a couple of months ago for our engineering all hands. So those will probably change over time. We haven't fixed that yet. But that got the initial ideas flowing. The idea with inputs, outputs, and transformations is that we wanted to follow the Telegraph model. So Telegraph is actually the most popular open source project we have by orders of magnitude. It's deployed. We don't have any reporting feature in it, so we have no idea how widely it's deployed. I'm certain it's in millions, if not tens of millions, or hundreds of millions of servers worldwide. It is all over the place. And the reason that has happened is because we developed a plugin system. It's a couple of things. One, we developed a plugin system so that any external contributor could come in and add a new plugin without having to understand the entire Telegraph code base. But the other thing we did is we didn't limit it to just InfluxDB. And because of that, we've actually had competitors write plugins for Telegraph because we didn't limit where Telegraph could send data to. There are plugins for sending data to Datadog, SignalFX, Wavefront, Graphite, like all these other things. And we accepted those PRs because we wanted Telegraph to live as a successful open source project separately from InfluxDB. And that's the same goal that we have for Flux, the language itself. So I'll use an input as a way to highlight something that's going to be possible in Flux that I think is super powerful, and it's a feature that people have been asking for years. So basically, if you look at all of this, what we're doing here is we're essentially like querying a MySQL database to get some reference data, and then joining that up with our time series data as we're querying it together, right? basically being able to hit another data store that holds reference data is the feature request that people have. So the stuff that we can highlight here are, we can see we have imports. Now, MySQL is probably going to be built into the standard library, but users will be able to define their own packages and their own namespaces and share them with each other so they can import stuff. Obviously, we're pulling data from a non-InfluxDB source. For now, we're just passing in a raw SQL query. Over time, as the Flux planner matures, it will be able to actually convert Flux queries into MySQL queries or whatever the data source is. So ideally, it will be able to push down as much of the processing logic into the remote source as it possibly can, so it just gets the subset of data that it needs to satisfy the ultimate request. The other thing we see here is we're loading a secret. We need the connection string for the MySQL database, and obviously that's going to have authentication information, so we have a function that we're going to call loadSecret that just has that built in. At launch, what we're planning on having is basically a plain text secret store, which is obviously not the recommended way to run in production, but that makes things easy. And we'll also have integration with HashiCorp's Vault. And the design will be that we'll, later on, if people want to add integrations to other secret data stores, that's great. We'll take them. We want to support as much of that as possible. At launch, the plan is Vault and plain text for people who are just on their developer laptops. The other thing I think is important to highlight here is you can shape your data in Flux. This is something that's kind of difficult to do in InfluxQL. You can rename columns. You can copy and duplicate them. And I'll show more of those examples. So finally, what we're doing here is, we have the reference data query, which is customers. We have the time series data, which is data. And then we're joining those results together. And what you can see is we're joining on the ID column. In Flux, you can join on any column, not just time, which is, again, not something that was possible in InfluxQL at all. And that opens up a whole set of possibilities that just weren't possible before. So the other big thing is outputs, right? So 2 is basically writing back to InfluxDB. And the idea is we'll have outputs to a bunch of other, basically, data syncs where you'd want to write data to, like to Kafka, to a file, to S3, to other databases if you want. Ultimately, outputs are for what we're calling tasks. So tasks are basically all of the capacitor functionality, right? The task system is what we're representing in InfluxDB 2.0 to represent that capacitor stuff. So apologies for the wall of code, but we're going to jump through a quick example. I'll hand wave over a lot of this. The idea behind this example is we want to create alerts for monitoring disk utilization. And we want to create a warning if we're at 80% utilization, and we want to create a critical alert if we're at 90% utilization. So the things I want to highlight from this query that I think are interesting. One, we have this option syntax for tasks, right? So option task equals this. We give the task a name, which identifies it. We say how frequently we want to run this check. We're going to run it once every 5 minutes. Separately, last. This is a long requested feature, which is, give me the last data point. I don't know what time range it's in. Right now, you actually have to specify a time range. In InfluxDB 2.0, you won't have to specify a time range. You'll be able to get at the last data point just by saying this. This has been like an open feature request for like 4 years. So an add column, this is another example of basically decorating the data, right? We know what the alert level is, so we're going to add this column into the data set. So again, this is showing the ability to shape the data as you're doing queries, which I think is really powerful. And then finally, we're sending the data out to InfluxDB. Now in this case, we're just writing it to the local InfluxDB instance, but you'll also be able to specify a remote system, right? So you could write to another open source InfluxDB, you could write to InfluxDB Cloud, you could write to Enterprise, whatever you want to do. And the idea behind all of this, one thing that I think is super powerful, and again, it gets at the idea of like creating primitives that you can build on top of, which is, in this case, what I'm trying to do is I'm trying to separate the idea of alerts from notifications, right? Not everything that is an alert condition is something that I need to be told about at, say, 3 a.m., for example. There are very few things that I need to know about at 3 a.m. Most other things I can figure out when I get into work the next day and I can see things, right? So separating that out and having a time series data store as the thing that stores all of your alert stream means you can do that. This one I'm really going to hand wave over. But this is basically a separate task that defines when to send critical alerts. And in this case, we're going to send the alerts to Slack, right? So the first thing we want to do is we want to see what the last time was that we actually sent out a notification, what the last alert time was. So we have this state. Capacitor right now doesn't have the state of previous notifications that were sent, so this is something it doesn't currently do. We can pull back this state and then use it in our query and say, okay, look at the alerts time bucket to pull back those alerts, and just give me the stuff starting from the last notification time. The now function is built in. That's basically like, now. The other thing I haven't shown before is the map function. So this will iterate over the records in every table within the set of tables that get sent down. Drop is another one. That's another like one of those data shaping things, so we can kind of get rid of data that we don't care about. String interpolation is a big one. Having string interpolation means this turns like the combination of tasks and the time series and Flux and string interpolation turns this into, it could be a real-time notification system, but it could also be a reporting tool, which I'll show you an example of in a second. So finally, what we're doing is sending the data to Slack. And the other thing we're doing is we're also sending the fact that we sent those notifications to InfluxDB. So we're just saving that as a separate time series that we can query later. So this is an example of like a reporting thing, right? I mentioned we have 2 alert levels. We have critical and we have warn. And I don't care about the warn stuff. Like, I don't need a page on the warn stuff. So what we're going to do is we're just going to send an email out every day at 5 a.m. So this highlights another thing that we have in tasks, which is we support the cron syntax. So if every specification is a little too simple for you, you can get more complex behavior with cron. We're creating the body variable, we're querying the data, and then importantly, we're using that body variable to build up the text of the alert body, of the message that we're going to send out. Right, so that highlights the fact that we have closures in the language. And then finally, we send that just out to SMTP. We're not going to bother logging this because it just runs once a day. The risk of having that happen multiple times is unlikely, so I don't really care. So one other thing to highlight about all of this work on tasks is tasks have run logs. So this is a first-class citizen in the InfluxDB 2.0 API. Again, one of the biggest problems we've seen crop up with people's usage of capacitor is it's frequently hard to understand what's going on. People don't know what's happening behind the scenes. So what we've done is we've said the task subsystem that's responsible for running all of this stuff in the background for you will actually log the outcome of those runs to time series that can then query later. Now, we have it exposed as an API, but there's basically a separate like system bucket per organization, so you can just query that task run log as just another time series. Logs are ultimately tons of time series all mixed into one, and we view that all as the same kind of thing. Now, all of that seems like a lot of ceremony and a lot of code just to get some simple alerting set up. But I use that as like a starting point to highlight what's possible. Ultimately, we're going to have stuff in the user interface in InfluxDB 2.0 that will hide a lot of that complexity. So if you want basic monitoring and alerting rules, you won't have to write a task. You won't have to write a Flux script, right? You won't have to define all this stuff. You'll have a point-and-click interface like you'd have in any standard monitoring tool to define the basic rules. But What's happening behind the scenes is it's actually defining this stuff as tasks and all these other things so that if you have more complex functionality, more complex alerting that you want to do, you can drop down to the lower level primitives. All of this is built on top of these like atomic units, so you can put them together to get something more complex over time. There's going to be an API for defining dashboards. I mean, actually there already is one that exists. One thing we're also going to have is bulk import and export. So basically you can specify a bucket, a time range, and a predicate, and you can get a bulk export of actual compressed data, not line protocol. The problem with line protocol is it's like, if you try to export that, it's like this massive amount of data, right? So the bulk export will give you compressed, basically like TSM blocks, that you can then later import to some other system. And what that means is you'll be able to move from, say, an open source InfluxDB to cloud, or from one open source one to another open source one seamlessly using this functionality. And ultimately, this is actually 3 separate products, but the same API. So essentially, it's the same API that's going to be in open source, the same in cloud, and the same in our enterprise offering. So you can seamlessly move between those different things without having to change your code. And the interface for this is all going to be delivered through a command line interface, as well as the user interface, which, as I said, is just going to be built into InfluxDB 2.0. I'm really excited about where we're going with this. It's the fact that the API is the same in our cloud service versus the open source thing is something that I don't think I've actually seen before. And our goal is to basically launch the open source stuff early, launch the cloud stuff shortly after, or launch the two about at the same time. And people will be able to work with that and actually define all of this complex functionality. On the topic of Flux, tomorrow's our workshop day. Nathaniel Cook, who is here somewhere, he's right there. He is the lead developer of Flux, and he and I will be running basically like an ad hoc workshop in one of the rooms. So it's not going to be like slides or anything like that. If you just want to have a conversation, talk about language design, talk about nerdy Flux stuff, we're going to be around, and we'd love to get your feedback. So that is all I have. Thank you. I guess I have time for a few questions. Over there? Yeah?
So with a lot of people adopting AWS, do you guys have any plans to build a plugin for CloudWatch metrics?
I can't quite hear you. Sorry.
Yeah. So my question was, a lot of people in the industry adopting AWS, do you guys have plans to build plugins to integrate with CloudWatch metrics into InfluxDB?
Plugins to integrate with what?
Yeah, get data, metrics data from
CloudWatch metrics. Yeah, absolutely. Our goal is to be able to have from data sources come from anywhere. So for example, Telegraph has, I think, somewhere around 200 plugins right now. The vast majority of those were written by people in the community, not by us. And our goal with the layout of the code is that people will be able to contribute new data sources. So CloudWatch is a perfect example. Any of the other cloud monitoring vendors, right, like New Relic, for example. If you want to pull your APM stats into an InfluxDB instance or work with them together, we want to enable that kind of functionality. And ultimately, that's what we'd like to see is hundreds of functions defined by a broad community of users. Yeah.
I have one more question, sorry.
Okay.
So a lot of times, all these thresholds and alerting and notification is based on a calculated metric. Basically, people would use 2 different metrics to calculate and then threshold on top of the result. So with Flux, will we be able to use Influx queries and then based on the output, can we threshold and notify?
Yeah, you can do calculated metrics. I didn't have an example in this slide deck, But basically, the join functionality, you can do calculated metrics. So you can do like error rates and stuff like that. So the math across measurements feature is already delivered in Flux today. And that feature request has been open for 4 years. So.
I was wondering what is the level of interaction between Flux and the backend? Does it get converted to InfluxQL and sent to the backend?
Or can you hold it closer?
Sorry. So I was wondering what is the level of interaction between Flux and the backend?
And the backend?
Yeah.
So yeah, the level of interaction between Flux and the backend. So it depends on the data source, and it also depends on which product we're talking about. Within open source InfluxDB, it's not like an RPC call or anything like that. So Flux has a direct like client, it's an embedded database basically. So the Flux engine pulls directly from the storage engine and then works with the data there. In say our cloud or our enterprise offerings, what happens is it's essentially a MapReduce that gets run on the fly, right? So the Flux query planner figures out what it can push down to the remote data nodes. They do that computation, and then the Flux coordinator node that received the query combine those results and then send it out. That's going to get more complex over time, and also, like I said, for the different data sources, as the query planner matures and gets more complexity, it will be like ideally like a data source like SQL, you can push down so many things, right? So many things within a Flux query could actually be pushed down to a SQL database. So ideally, it would do that, and then the Flux engine would get the minimal set of data to do whatever the post computation is to return a result.
So what happens to UDFs in Flux? Like,
Yeah, so the question is, what about UDFs?
UDFs, yeah.
Yeah, so we will support UDFs. We haven't figured out an exact plan for what that looks like yet. For people who don't know, UDFs are user-defined functions in Capacitor. Basically, they allow you to write a function in whatever language you want to do it in, as long as you can have a socket and protobufs. You can do that. So basically, Capacitor does that, and it sends data to another process that you're running and hooks up that way. So we want to enable UDFs in Flux. We just haven't figured out exactly what that'll look like. Now, users will be able to define a bunch of complex functionality in Flux, the language. and I'm now getting the hook. So, but I'll be around all day, and like I said, Nathaniel and I are going to be doing a workshop tomorrow morning at the workshop. So please come see us. Thank you.